Okay, 4.4, the fundamental theorem of that calculus, not algebra, calculus. Pretty important, obviously, if it's the fundamental theorem. Okay, so here it is. The fundamental theorem of calculus says if a function f is continuous on a closed interval, so it has to be differentiable. If it's continuous, it's differentiable. We've discussed this like all first semester, right? And f is an antiderivative of f on the interval a to b. Then the integral from a to b of f of x dx is the antiderivative of b minus the antiderivative of a. So what that tells me is that I'm going to find the antiderivative, and I'm going to plug in b, which would be my upper limit, and subtract when I plug in a. That's what it is. Got it? Everyone good? Okay, so this is your page 250, Cadence. So we're going to do antiderivatives. So the integral from 0 to pi over 4. Basically, I read that exactly like a summation, didn't I? Okay, the integral from 0 to pi over 4 of secant squared x dx. So from your rules, what is the antiderivative of secant squared? Tangent. So, why is it jumping? I don't even know where it went.
Right there.
Oh.
You silly goose. Almost.
Oh, well, this is just an explanation of that. Do I need to go through it?
No.
Okay. This is in your textbook if you want it. I will point out a few things real quick. So we will find the integral from a to b. So we find the antiderivative.
Yep.
And then we put a bar. There is no plus c. This is called a definite integral. What we did before were indefinite. They were forever plus c. Definite, no plus c. Got it?
Got it.
Okay, so, and it means the sum, but by doing this from here to here, we don't have to do the sum. So if I have the antiderivative is x to the fourth over 4, we put 3 to the fourth over 4 minus the lower limit 1 to the fourth over 4. So 3 to the fourth is 81. So it'd be 81 over 4 minus 1 over 4.
Equals 20.
So it would be 80 over 4, which would be 20. Okay? That's how it works. So let me see if I can get to that example without... Okay, so we weren't even supposed to be. When I hit once, it skipped like 6 slides. Let's do this one. Sorry. We will do the other one eventually if you want to leave it there, but we're going to start with this one. I was like, that seems like a big jump. But
How many lines do I need?
I don't know. 3? Okay, so the integral from 1 to 2 of x squared minus 3 dx. So the first thing I do is find the antiderivative. So the antiderivative of x squared is add 1, divide by.
Oh, I forgot about
So 1/3 x cubed minus 3x. And then you just put this straight line and you go from 1 to 2. So we plug in our 2. So you have 8 over 3 minus 6. Minus 1 over 3 minus 3.
Wait, can you put 2 in? Yeah, it's not
Yes. Yes. 2 cubes 8.
What about the 1?
1's right here. This is f of 1 and this is f of 2.
Oh, okay.
Okay, so 6 would be 18 over 3, wouldn't it? So that would be negative 10 over 3. And 3 would be 9 over 3. So it'd be negative 8 over 3, but then it would be positive because of negative out there.
Negative 2/3.
So you get negative 2/3.
And then what do we do?
That's the answer.
Okay, so that bar thing is not a bracket, just a straight line.
It's just a straight line. You can make it a bracket if you want, but I don't care for the bracket.
You're right, I needed 3 lines. Don't touch him. Don't touch him. Can you stand there? Go stand. What are you looking at? Or what?
No, I was just looking. Okay. So the next one, 1 to 4 of 3 square root of x dx. Okay, so how do I find the derivative of this?
X is a half.
X is a half, and the 3 goes where?
2. 3 and 2.
Doesn't it go out front?
Oh, yeah. No, I don't know.
That
Yes.
the constant goes out front?
Yes.
So we're going to have 3. Now I'm going to use a bracket. Okay, and this is x to the 1/2. So add 1. And then, Jaden, you were right. Add 1 would be x to the 3/2.
Yeah.
Multiply by the reciprocal, which would be 2/3. And then from 1 to 4. Now we can do some simplifying here, can't we? 2/3 times 3 is 2. Now you can bring the 2 out and do your subtraction and multiply it all by 2, or you can leave it in. Which would you rather?
What's easy?
I would typically pull the 2 out because 2 is fine, but what if it's like 15?
Pull it out.
Okay, so we're gonna do this simplification. So the 3's reduced, so I'm gonna have a 2, and then I'm gonna have x to the 3/2 from 1 to 4. So I plug in a 4. So 4 to the 3/2 minus 1 to the 3/2.
Is it always minus?
Yep, always. Because you're finding the difference between the two. It's an overestimate and an underestimate. Okay, well, 3/2 means the square root of 4 cubed, doesn't it? The exponent 3/2 doesn't mean the square root. Isn't the square root the 2? Yeah. So the square root of 4 is 2. 2 cubed is 8. So 8 minus 1. So 2 times 7 is 14. Again, we could have left that 2 in there just fine. But if it's another number, would it be easier to multiply once rather than twice? Okay.
Wait, how do I find the first thing? I add and then divide?
Mm-hmm.
Okay.
Add and divide, but since it's a fraction, we multiply by the reciprocal. Okay, now we're going to go with the secant. So 0 to pi over 4 secant squared x dx, and I absolutely hate that they don't put parentheses around that x. It's gross. And Cadence, you already told me it was what? Tangent. So I have tangent of x from 0 to pi over 4. So plug in. So tangent of pi over 4 minus tangent at 0. So what's the tangent of pi over 4?
Good question. I don't remember how to do this.
45, 45, so it'd be square root of 2 over the square root of 2, so it'd be
1.
1. And then the tangent of 0 is
0.
0, so the answer is
1.
1. Okay. We got a problem here. Is the absolute value continuous?
No.
It's not. So, if I were to graph this, because I only want from 0 to 2, correct? Okay. So, if I plug in 0 to this equation, I get 2 minus 1, which is 1. If I plug in 2 this equation, 4 minus 1, which is 3. So it had to hit somewhere, right? And it hits, and I could find out where it hits by setting it equal to 0. So 2x minus 1 equals 0. So 2x equals 1. So x equals 1/2, right? X-intercept. So what we're doing is finding this areas. But is that continuous? Are those two pieces continuous? No. So what am I going to have to do? I'm going to have to find the area here, the left and the right, and do what with them?
Subtract them. Add them.
Add them, because I want this and that. So I'm going to have to do this not once, but twice.
How do you do a left and right side?
Well, I'll show you. We just needed the picture. So when we do integrals, we will be drawing ourselves pictures. Because if we have something like that that makes it discontinuous in the middle, we need to break things up. Okay? So what we're going to do is we're going to go from 0 to 1/2. Yeah. Okay, 0 to 1/2, and we're going to be doing the negative 2x minus 1 dx. Now, the reason why this is negative is what is the slope of that little portion? If I cover,
Down.
it's down, it's negative. So we have that negative in front of it. Okay? Because in absolute value, everything that comes out is positive, but we have to acknowledge that this is going down. Okay? And then we're going to plus from 1/2 to 2 of 2x minus 1 dx. So what do you notice? My original problem was from 0 to what?
So 2.
To 2. My original 0 to 2. Am I still covering from 0 to 2?
Yes.
I'm just covering it in 2 pieces. If I had to do 3 or 4 or whatever, could I do that?
Yes.
Yes. Okay. Why did we have the negative on the first one?
Because it's going down.
It's going down. It's that left-hand part. Okay? So now I just do the problem. So I'm assuming we're going to, factor out this negative, yes?
Sure.
Or actually, let's distribute it. Why don't we distribute it? So this would be a negative 2x plus 1. That might make it easier, huh? Okay. So antiderivative of negative 2x plus 1 So add 1, so we get x squared, and divide by it. So negative 2 divided by 2 is
1.
negative 1. Yep. Plus x.
X.
And that is from 0 to 1/2. Plus, we'll add 1 divide would just be x
X squared.
squared minus x.
Yeah.
And we probably should put square brackets around this because we have 2 of them, huh? And this one is from what?
Uh-huh.
1/2 to 2. So we just plug in. So 1/2 squared would be 1/4 times negative 1, which would be negative 1/4. Minus 1/2. Minus, when we plug in 0 to this whole thing, what are we going to get? 0. So just put 0. Because both of them would be 0, yes? Okay. So plus,
I thought it was negative. No, that was just
this is
from
just, this right here. Would that help?
the plus is from the front. Okay.
The
I
plus,
see now.
okay, we'll just do this. That's fine. Sometimes we need more brackets to start so we can keep our brain separate, right?
Yes.
So now we're plugging in 2.
Yes.
So 2 squared is 4 minus 2. Minus 1/2 would be 1/4 minus 1/2. Okay, so since this is like all addition, subtraction, I could distribute and combine in any kind of way, right? Okay, so this is going to give me 2, positive 2. This is going to be negative 1/4 plus 1/2. And then we're going to have minus 1/2 minus 1/4. So my 1/2s do what?
Go out.
They zero out. So negative 1/4 and negative 1/4 is negative 1/2.
Yeah. Yeah.
So 2 would be 4 over 2. So 4 over 2 minus 1/2, sorry, not divided by, which give me 3/2. They have 5/2.
They're wrong. Let's move on.
Oh, I messed up right here. See if you guys can see where I messed up.
I don't know. You got fractions.
No.
Is it in the beginning?
What are you plugging in?
Uh-huh.
1/2. How did I get negative 1/2?
On which side?
Right here.
You don't. You get
You
positive.
get positive 1/2. Can you look at how I wrote it and see why I put negative 1/2? Look up here, right here.
Oh.
Doesn't my bracket, since I didn't join it, doesn't my bracket look like a negative?
Yep.
Yep. So this should be positive. Okay, so now I've got negative 1/4 plus 1/2 plus 2 minus 1/4 plus 1/2. Let's try this again. 1/2 and 1/2 is a whole, right? So that gives me 3 minus 1/2. So 3 would be 6/2, right? Because 1/2, 3, and 2 is 3. So 6/2 minus 1/2 is 5/2. Now, are negative and positives going to be a major thing? Yes. Don't mess them up.
Wait, where did you get the other half from? Oh wait, never mind.
Got it?
Yeah. I think that's good.
I think that's good. Okay, your calculator will do
Don't tell me that.
definite integrals. Well, it's not going to show you steps, but it is going to show you answers. So if you go to math, and then you go down to, okay, it doesn't say definite, but it says finite. Isn't finite the same as definite? Okay, definite integral. Now, yours, Jaden, works exactly like this. You fill in the blanks. Yours, you have to put the lower limit, comma, the upper limit, comma, the function, comma, the variable.
No, thank you. Calc chat.
So, takes a little bit more work. On the derivative calculator that I shared with you earlier,
I think either works really good or it just confuses me.
oh, I always lose it. Okay, on the derivative calculator, up here, see it says integral calculator?
Yeah.
Integral calculator. And you can put an integral in. We just did absolute value, right? It was absolute value. So ABS of, what was that equation? 2x minus 1. Okay, and you can have it definite or indefinite. You go to options, and you just put from 0 to 2. And go. And it has the answer. It's 5 halves. If you need it to show you steps, you tell it to show you steps.
Cool.
On these, I would probably say just check your answer. Their steps are going to be different than our steps. Okay. Oh, they even got a Santa hat. Look at that.
Aww.
They're festive.
We don't need to do that.
Well, we can just talk about it real quick. It says find the area of the region. When I talked about that, I said area, right? Integrals are finding areas under curves. I think I've said that before, and that's what we're doing. So it says find the area of the region bounded by the graph. So we have, this is a parabola, yes?
Yeah. Yeah.
Yes. So I know it's going to be a parabola. I know the y-intercept is 2.
Yep.
Because of the 2. And it says from 0 to 2 on the x-axis. So guess what I do? I plug in 0. And if I plugged in 0, I get 2. And then I plug in 2. So that would be 8 minus 6 plus 2, which would be 4. So something has to be happening in the middle of there. We want to make sure that it's not coming all the way down. There's a couple things we can do. We could find the vertex. From the vertex of a parabola is negative b over 2a. So that would be 3 over 4. So we know it's at 3/4. So if I plugged 3/4 in here, I don't think I'm getting anything negative, do you?
No.
Nope. So this graph comes down up like this. And I want this region. So I want the integral from 0 to 2. of 2x squared minus 3x plus 2 dx. Sketching the graph will help you visualize what you're doing. Was this problem any different than what we just did? No, they just worded it different. So I'm pretty sure all I have are more examples. Do you guys want to do more examples? Or are you good?
No more.
Okay.
So try the assignment.
I think Jaden's going to yell at me.
Yes.
Actually, that is the last example I have.